Hi everyone, today we're going to be talking about inequalities. An inequality is a mathematical sentence that contains the signs less than, greater than, less than or equal to, or greater than or equal to. So any numerical sentence with this symbol in it is going to be called an inequality. The word inequality means these aren't equal, like an equation where we have an equal sign, both sides are equal. Whereas in an inequality, they're unequal, so both sides will not be the same. So when you see these signs, or when you're trying to translate from a sentence to write an inequality, there's some key words for each of these. So for the less than sign, you'll see either is less than, or you'll see something like is fewer than. So either of those are some keywords that you're going to see to use the less than sign. Go ahead and write those down, and notice that it says is less than, whereas when we did our translations unit and saw the word less than, that just meant subtraction. So having that whole phrase is less than is important there. Our next sign that we have is the greater than sign. So you're going to see something like is more than. Again, with the is in front of it, it doesn't mean addition, it means the greater than sign. Is greater than. Or you're going to see something like exceeds. All of those words would make you think about the greater than inequality sign. Next we have the less than or equal to sign, so we're going to see something like is less than or equal to. And make sure when you're saying that out loud, you're saying the or equal to part, because if you just say less than, then we're going to use the sign that we talked about first, rather than the one with the line underneath. And a good way to remember about these is that since it has that line, it looks kind of like an equal sign, but then we change that top line to whichever inequality sign we were talking about, the less than or the greater than. And then we have is no more than. Or you could have is at most. So each of those phrases would be telling you to use this less than or equal to sign. Last but not least, we have the is greater than sign. Is greater than or equal to, is greater than or equal to. Again, it has that line underneath to tell us that we're kind of combining an equal sign, but then we change that top line to a greater than sign. The other phrases you could use are is no less than, and the last one we have is at least. So go ahead and take a minute to finish writing those down. Okay, so moving on to some examples of these. It says write each sentence as an inequality. So the first one, less than 50 students attended the game. So less than, we're going to be talking about the less than symbol that looks like this. And we're talking about 50 students attending a game. So S is going to stand for students. S is going to be the number of students that actually attended. We don't know what it is, but we know that it's less than 50. So to write this inequality, we're going to say S is less than 50. So then that kind of becomes translated to, well, if S is the number of students, we know that it was under 50. It can't equal 50 because it didn't say less than or equal to, otherwise we would have drawn the line underneath to say both, but in this case it was just less than. Now in number 2 we have going to the movies will cost at least $15. And up above we said that at least was going to mean greater than or equal to. And what we're talking about here is the cost of a movie, so maybe we'll just call movies M our variable in this case. So we're going to say that when you go to the movies, you're spending greater than or equal to $15 in this case. So you're definitely spending $15 or more in this case. The at least was saying you're not going to get out of there with by spending less than $15. So that means you're spending at least $15 at that movie. Okay, so once you've been able to translate an inequality into something like x is greater than 3 or x is less than or equal to 3, the other thing we need to know how to do is graphing the inequalities. So just a key to use for all of these graphs you're going to be using an open circle that looks like this, so we'll just call that open circle. We're going to use that whenever you see the less than or greater than sign. And that's going to be opposed to a closed circle that you're going to shade in fully. So we'll call that a closed circle. And those are only going to be used when we have a less than or equal to sign or a greater than or equal to sign. So when we're graphing something like this first example, number 1, we have x is greater than 3. We're going to find that number on the number line, so we're talking about 3, and we're going to draw a circle right above it. Now, since we have the greater than sign and not the greater than or equal to sign, we're going to leave that as an open circle. And we're saying that x, whatever you fill in for x here, is going to be greater than 3. So a number that would be greater than 3 could be 4, could be 5, could be 6, and so on. Any of those numbers over there are going to be greater than 3. So that means that we're going to shade on this side of our open circle to indicate that x could be in any of this shaded area right here. And there's our graph for that inequality. So the next example, x is less than or equal to 3. Again, find that number on the number line. In this case, it's 3 again. So we're going to draw our circle above it. But this time we have the less than or equal to sign, which means we need to make this a closed shaded circle. So go ahead and fill that circle in. And this time we're talking about x is less than or equal to. So a number that would make this inequality true, we could say, well, 2 is less than or equal to 3. But 3 is also less than or equal to 3 because 3 is equal to 3. So that's why we're allowed to shade that circle in there, because our x could be 3. In the first one, it was x is greater than 3, so it couldn't be 3, and that's why we left it unshaded. So back to this example, x is less than or equal to 3. We could say 2 is less than or equal to 3, 1, and so on to the left here. So we're just going to shade in every part of this number line to the left of our closed circle. And there you have your inequality graphed. So right below it, you have 2 more examples. I'd like you to try those on your own. So go ahead and pause the video and unpause when you're ready to start checking your answers. Okay, so hopefully you took a minute to try these both on your own, but let's go over them just to make sure you did it correctly. So in number 3, we had -4 is greater than x. So start by finding your number that is dealing with an inequality. So we have -4. We're going to draw a circle over it. And we have a greater than sign, so we're not going to shade in this circle. It is going to be an open circle. Now we're saying that -4 is greater than any value of x that we put in there. So any number that you fill in here to make this true needs to be something that is less than -4, which means we need to shade to the left of -4 in this case. An x value that you could put in there would be -5, because then -4 is greater than -5. So be careful with those negatives because negative numbers do go backwards like we know. And then in number 4, we have -5 is less than or equal to x. So go ahead and find your number. We have -5 this time. And it's a less than or equal to, so we need to shade that in. And we're talking about an x value that when you plug this in needs to be greater than or equal to this -5. So something that we could fill in here would be 0. 0 is going to be bigger than -5. And we would read that as -5 is less than or equal to 0. And we know that's true. So that means that any of these x values to the right of our -5 are going to hold true for this inequality. So we're going to shade everywhere to the right here and make sure you complete that arrow to say that that goes on forever, not just what we have on our number line here. So hopefully you got those right. If not, please go ahead and make those corrections. Okay, so next we're going to talk about solving inequalities, and we just came out of our solving equations unit, and solving inequalities is very similar to solving equations, so this should seem like something you're already familiar with. So we're going to start by looking at number 1, 3x is less than 9, and we want to get this into the form where we just have the x by itself. So the same thing that when we were solving for our equations, we were looking to isolate the variable and get x alone, or whatever the variable was. That's what we're trying to do here. So we ask ourselves, okay, well, what's happening to x here? And we're saying, well, x is being multiplied by 3. So in order to get x alone, I'm going to divide by 3 on this side. And then it's the same thing with our equations that we did. We need to divide on the other side as well. This keeps this balanced, and that doesn't unbalance what we're trying to talk about. So we know that 3 divided by 3 is 1, so we can cross that out, and 1 times x is just x. And then 9 divided by 3 gets us 3. And this inequality symbol, this less than symbol, is going to come right on down. And now this becomes our solution to this inequality. And you can go ahead and graph that just like we did above. So x is less than 3. That means that we are going to put an open circle above 3. And x is less than 3, so 2 is less than 3. That makes that true. So we're going to shade everywhere to the left of that open circle. And there's our solution to that one-step inequality. Now in number 2, we have 1/2 x is greater than or equal to 2. And once again, all we want to do is get x by itself. And we talked about in our last unit that 1/2, that's a fraction as a coefficient. So remember, you need to flip your fraction over and multiply by it. So we're multiplying by the reciprocal on both sides. And when we do that, multiplying by reciprocals, 2 times 1 is 2, 1 times 1 is 2. That gets us 2 over 2, which is just 1. And that leaves us with x. So x is greater than or equal to 2 times 2 over 1. That just gets us 4. So there's our solution to that one-step inequality. So go ahead, find the 4. This time we're dealing with a closed circle because we have the greater than or equal to sign. And if we're talking about x is greater than or equal to 4, well then it could be 4, or 5 would make that a true statement, or 6, and so on. So we're going to shade to the right of our closed circle in this graph. Okay, so go ahead and turn your paper over to number 3. We have 2 more one-step inequalities to solve. You can try these on your own by pausing the video and then checking, or you can follow along if you want some more practice with this. So we have x plus 4 is less than or equal to 9. Again, we want to get x by itself. So right now we're adding 4 to x, so we're going to do the opposite by subtracting 4. And whatever you do on one side, you need to do on the other. So that's going to be 4 minus 4 gets us 0, and we're only left with x on this side. 9 minus 4 gets us 5, and that inequality symbol just comes right on down, and we have x is less than or equal to 5 in this case. So we go to our 5, we put a shaded circle above that because it was a less than or equal to sign. And if it's less than or equal to that, then a number that might satisfy that would be -2 is less than or equal to 5. So we're going to shade everywhere to the left of that shaded circle. And then over at number 4, we have x plus 7 is greater than 12. So again, get your x by itself. Right now we're adding 7 to x, so the opposite of that would be subtracting 7. And we're going to do that on both sides. 7 minus 7 is 0, that just gets to go away, and we are left with x. 12 minus 7 gets us 5. So x is greater than 5 becomes our inequality solution for this. And we're dealing with a 5 again, so we go over to 5, but this time we need an open circle. And if x is greater than 5, an x value that might work there would be 8 is greater than 5. Well, 8's going to be to the right of this 5 here, so even though it's only a little bit of our number line, we're going to shade all the way to the right there. Okay, so far the inequalities that we've had to solve have been really similar to solving equations. So we're going to fill this in and say solving equations is the same as solving inequalities is the same as solving equations because you undo the operation given. So just like we did in the last two, we saw addition, so we use subtraction. On the front, we undid the multiplication and the division. So the only difference here with solving inequalities is when you are multiplying or dividing the variable by a negative number. So these negative numbers are going to be tricky here. That means you need to flip the inequality sign. So go ahead and take a minute to fill this in. This is a really important note, and we're going to try some examples like this, and I'll show you what I mean. So in this first example here, we have negative 5c is greater than or equal to 25. So right now, negative 5 is being multiplied by c. So we're just trying to solve this like normal, so we have to think about, well, what's the opposite of multiplying? That would be dividing. And since we were multiplying by negative 5, we need to divide by negative 5. So I'm going to divide by -5 on both sides. So this is where my note comes in. It says when you divide a variable by a negative number, you must flip the inequality sign. So we're dividing by a negative number here. -5 divided by -5 just leaves us with 1. So we have our 1 times c, which is just c. 25 divided by -5 gets us -5. But this inequality sign, we started with a greater than or equal to sign, but since we're dividing by a negative number, that's got to flip around. So that's actually going to change into a less than or equal to sign. And now here is our final answer. That's going to be the inequality that represents these solutions. So now we have c is less than or equal to -5. So we're going to go ahead and graph this. This is going to be a closed circle on -5. And c needs to be anything less than or equal to that. So -7 would be less than or equal to -5. So we're going to shade everywhere to the left of our shaded circle. Okay, so moving on to number 2, let's try this again. X is being divided by -2 here. So to undo that and get x by itself, we need to do the opposite of division, which is multiplication, and we need to multiply by -2. So once again, our rule, this note up above, is going to be when we multiply the variable by a negative number, we need to flip the inequality sign. So go ahead and isolate this variable to -2 times x divided by -2. These -2's are going to cancel each other out and become 1. So we just have our x left over. -2 times -2 is +4. We started with a less than or equal to sign, so we need to flip this so that we are paying attention to those negative rules, and now our final answer becomes x is greater than or equal to 4. So then go ahead and graph this on your number line. We're going to put a closed circle on number 4. And a number that would make this true, we could plug in a 5 for x here and say, well, 5 is greater than or equal to 4. So we're going to shade to the right of that closed circle. Alright, so we just have a couple more examples. We have this first one, number 3. X divided by 3 is less than or equal to -1. So x, to get it by itself, it's being divided by 3 right now, so we're going to multiply by 3 on both sides. 3 times x divided by 3, those 3's go away, and we're just left with x. And -1 times 3 is a -3. Now, we had a -1 here to start, but the number that we multiplied by on both sides was a +3. So that rule where we need to change the sign when we multiply by a negative is not going to happen here because we multiplied by a positive number. So the solution here is just going to be x is less than or equal to -3. So go ahead and put your closed shaded circle above -3. And if we're talking about x is less than or equal to that, something that might work for that would be -5 is less than or equal to -3. So we're going to shade to the left of that closed circle, and there's our solution. And our last example for today, we have 6z is greater than or equal to -36. So right now 6 is being multiplied by z. We're going to do the opposite and divide by 6 to get that z all by itself. Now we're dividing by a positive number, so that means we don't need to flip our inequality sign to the other side. So this is just going to become 1 times z, which gets us c. -36 divided by +6 is -6, and our inequality sign stays the same way, so we don't need to flip it. And there's our last solution. Go ahead and graph that, a -6 with a closed circle above it. And z is greater than or equal to that, so something that's greater than or equal to that would be 0. 0 is bigger than -6, so we're going to go ahead and shade all the way to the right there and use our number line to say that that's going to keep going. So go ahead and finish filling in those notes. Feel free to go back into the video if you missed something, and thank you for listening today. Have a great day.